So, welcome everyone. I see that people are slowly joining the meeting. We'll give it a few more seconds until there's a few more. And I think we can start. So yeah, welcome everyone. My name is Moritz Meister. I'm one of the lead engineers working on the feature store functionality at Hopsworks. And today I would like to show you if you are a weights and biases user, what to do with your model that you've trained using weights and biases once you're done. So basically how to deploy that model and also what it means to deploy a model. And we'll do that using Hopsworks, of course. So let's take a step back. I found this survey or the results of a survey, basically how broken is MLOps. And if you look at this graph or at this diagram, you will see that in this survey, what Algorithmia found is that about 64% of all companies take a month or longer to put a model into production. So even if you have great ML development tools like weights and biases, you also need to be able to deploy those models, right? To actually harvest the value of those models in your business. So what does it mean, MLOps, and to deploy a model? And for that, I would like to take a step back and look first at what or how do ML models generate value. And for that, we need to understand different use cases. So on the bottom part here, we have the more traditional ML use cases, like, for example, where you just do analytics on a lot of data, for example, training an ML model like a clustering method to learn the structure of your customers, basically just to understand your customers better. What we mean with operational ML is when you take a model, for example, a predictive model, deploy it into production, meaning that it's being run, for example, as an analytical model where all your customers are being scored every night or every week, and then writing those predictions back into an operational system like a CRM system. But the more advanced case, and also the case where you get actually more value, is when the machine learning model is tightly integrated into your product itself or the business itself. And that means that basically when the user interacts with your product or your shop or whatever, that predictions are made in real time. And that means basically you send some data to an endpoint, you make a prediction, send back the prediction, and depending on that, the user might experience something different in the product. So the big question is, how do we deploy those three types of models? You often hear analytical models often also referred to as batch models, and the operational models or operational ML as online models. And if we look at the status quo today and where all the challenges with MLOps are coming from, it's mostly because you have a lot of systems, a lot of sources of data, a lot of operational systems which need to make use of the predictions itself, and there's no clear structure defined on how to connect the source data to the output predictions to the output systems, right? So you get this kind of like a spaghetti salad, and oftentimes the pipelines connecting these systems are one-to-one. That means you might have one pipeline taking operational data, producing a report, but you might have another pipeline taking some operational data, feeding a batch application. So what we want to do is with MLOps, we want to sort this mess, right? So we want to have the source data on the left side and our AI or our machine learning use cases on the right side, which is basically the model training, model deployments as batch and online, but also the BI tools and the analytics reports. And ideally, we create this vicious cycle, which allows us to basically learn from the models we have in production, monitor and govern them, but also share and reuse the features that are used by those models to create new models for new use cases, or improve the models in the future. And here comes Hopsworks into the picture, because Hopsworks is meant as a central platform to basically provide the features or the feature store to power these ML or AI use cases. And the ideal goal is that for each of your data sources, you have essentially one feature engineering pipeline going into the feature store, but then you can have multiple models or multiple applications on the right side consuming the same features, so that you don't end up in this spaghetti pipeline situation where you have one pipeline for every feature and every model, but instead you have one pipeline for each data source, creating a bunch of features, and those features can be used arbitrarily in arbitrarily many models, basically. Under the hood, there's a bunch of abstractions that let you do that as a user of Hopsworks. On the one hand, we have the main abstraction, which are feature groups. You can think of feature groups like the API to write data into the feature store. And on the other hand, you have feature views, which are essentially a mapping from feature groups to models. Like the name suggests, it's a view over feature groups. And that feature views, or those feature views, are also the schema, the input schema to your model. So they are essentially the read API to the feature store. Along with that, we track or we provide search, versioning of the data, versioning of schemas of the feature groups, schemas of the feature views, statistics, tracking of code, and also the lineage between those concepts, of course. So now the question is, how does weights and biases fit into this picture? And for that, I'll take a quick step back and explain what weights and biases is all about, in case you're not familiar. Weights and biases are trying to, or are providing a tool which should make the life of a data scientist much easier, especially when data scientists work in teams. So the goal is to build better models faster, and they do that by providing these 5 main functionality pillars, so to say, which are experiment tracking. So if you do hyperparameter optimization to track those experiments, dashboards to show the results of those experiments, of models, training runs, and so on, versioning of data sets and models. You can also visualize data, for example, your training runs, if you collect any metrics from there. And also they provide tools and libraries to perform the actual hyperparameter optimization. So if we look back at our MLOps flywheel, you can see those 3 parts where basically weights and biases fit in. It's mostly the experiments and model training, the model registry, so basically versioning our models in weights and biases, but also to generate reports maybe in order to monitor models in production. However, what's missing is the model deployment, right? So you need to be able to, if you have a batch prediction job, to have some compute somewhere which reads up a bunch of new data, loads the model, scores the data, and writes back predictions somewhere. And that's where Hopsworks comes into play. So let's have a look at the API, which is mostly for the weights and biases users. In this webinar, I don't want to cover the feature groups so much. You can assume that basically the data engineers are the ones responsible for the feature groups, setting up pipelines, reading data from, for example, data warehouse like Snowflake, transforming or engineering the features and writing it into a feature group. And then the weights and biases users, mostly the data scientists, will go in and use the read API, which are the feature views. Yeah, the weights and biases users are using the feature views on this side. How does that look in code? Basically, it's very similar to the pandas join or merge APIs. You get references to a feature group in your notebook or in your training job that you're working on, and this gives you metadata objects that doesn't contain any actual data yet, and then you join those feature groups together by selecting the features you want. The feature store or the feature group is aware of the primary keys and the entities within the feature group, and therefore you don't need to provide a join key to perform this join. The feature store will figure that out for you. It will also figure out the point in time join. So if the feature group has an event time column, you can basically tell it, okay, there's a feature called fraud label, which is going to be the label. So then it will take all the other features only from time frames before the event time of the fraud label, and therefore preventing what we call data leakage, where you use data from the future to predict the past, which is kind of like a self-fulfilling prophecy, right? And then an additional important factor or important functionality that we think a lot of people oversee is that in order to make features reusable, they cannot be normalized or transformed yet. So what the feature view offers you is the possibility to attach additional transformation functions, right? So the data engineers basically write the untransformed data into the feature group, and then the data scientists can decide which transformation functions to use on top. Because a data scientist might train a model on subsets of data, for example, only US customers or only customers in Germany. And that means statistics change, right? So a min-max scalar will be different for those two models. So in order to not, so that the data engineers don't need to create two features for that, one for the US and one for Germany. Instead, we apply the transformation function when you get the data from the feature view for training a model or for scoring the data. And the feature view also tracks the statistics along with those transformations, which is very important to be able to apply the same transformations at serving time, essentially. And I'll show that later on in the demo. So what does it mean putting models into production? We have the feature view. First, we need to obviously train a model. And as I said, all the data that you read from the feature store is coming from feature views, and it's going through the transformation functions first. So what you would do as a weights and biases user, you read training data from a feature view that you've created, either into your own Python environment. This might be on some server that you use for development. You can use the Python SDK of the feature store to do this. You read up some data. You can either decide to read up the data into memory, into a pandas data frame directly, or you can also instruct the feature store to write the data in your favorite file format to an external location. For example, let's say you train your model on an EC2 instance somewhere. You might want to write the data as TF records to an S3 bucket, so you can easily read it up using TensorFlow when training your model. So then you would perform your experiments, which will lead you to your great model, which you finally push into the model registry to version it, to version it and have it also shareable and being able to discover it by other data scientists in your team or organization. So now, how do we get this model back into Hopsworks as a deployment, right? And how do we deploy that? There's two possible ways. I mean, one is batch scoring. In that case, you want to set up a Python job, or it might also be a Spark job that reads up the model from weights and biases, reads up again the same data with the same transformation functions, same statistics, scores all the data, and writes back the predictions either into an operational system, but you can also write the predictions back into a feature group to read them from the feature group itself. And the other type of model would be the operational model, where we take the model, deploy it into a container on KServe, providing a REST endpoint so that you can send basically primary key values to that REST endpoint. And since we know the feature view that was used to create that model, we can reconstruct the same feature vector or single feature vector for that primary key at prediction time from the feature store, pass it to the model, and then send back the prediction as a response. And I'm going to show you how that looks in code in a second. So now the only thing that's left is, of course, we're talking about MLOps, and ops means operations, and ideally we want to automate this whole process, right? We don't want to have to go in and manually create a serving instance or a serving job every time we retrain a model. So what we want to add is CI/CD. You can use Jenkins. In this case, I'll be using GitHub because it's the easiest to get started, I would say. And basically, we're using CI/CD and to watch some kind of trigger in a GitHub repo, which will trigger the process of reading the model from weights and biases from the model registry and creating a serving instance or serving deployment on Hopsworks itself. There's a lot of ways to use GitHub Actions to automate this process. There's actually no limit to your creativity, I would say. So usually what we see how our customers are using that is that they have a repo which contains all the deployments or contains references to all the deployments in the form of config files or job files. And then you basically have a directory in your repo which contains model deployments. And then every time they add a new model deployment, it consists of pushing a new directory to that model deployments directory containing the job config or containing the deployment configuration, and also the information about which feature view to use together with which of the weights and biases models. So, and then usually you have a script or an action, how it's called in GitHub, that performs those steps. So, or it listens basically, okay, every time there's a push to the repo, it looks at this directory and checks, is there a new model to be deployed, and then deploy that model to Hopsworks. And I'm going to jump right into the demo now. So I'm going to demo this with a serverless version of Hopsworks. We released that together with the latest release 3.0. You can think of it, it works much like weights and biases. You can simply get started, create a project, and start deploying models, and especially to get started and try out the platform. But there is also a managed platform if you want the full functionality, and also if you have more enterprise capabilities and you want more than one project and so on. In that case, you would connect your AWS account and we would deploy Hopsworks into your AWS account. So if you head over to sorry, I was not sure if the screen was shared. If you head over to hopsworks.ai, the easiest way is to click on the Start Now for Free button. That will give you the possibility to log in either with your Google account or with or create an account with your email. And then you'll get a project that can get you started, and also that allows you to run a bunch of demo or quick start tutorials. That's how it will look like. The fastest way to get started is actually running the notebook on Colab, for example. In this case, I'm going to use my own Jupyter notebook right now. So I have already an account and I've already created a project. So as I said, we want to focus mostly on the APIs for the data scientists, so the weights and biases users. In this case, I have already created 2 feature groups, and you can assume that there's a pipeline that runs, for example, in a regular interval every night or every week to update those feature groups. You can go in, look at the schema of the feature groups. You can have descriptions, the types of the feature groups. You can also see how often was new data committed to that feature group, especially if you're interested how fresh is the data in that feature group. Data engineers can add expectations also to the feature groups to prevent bad data to be written to a feature group. That's maybe important for data scientists to understand how is this data looking like. Also, you can look at the statistics of feature groups, basic descriptive statistics to give data scientists an idea of how does the distribution look like. You can also look at a preview of the data if you're just interested in getting a feeling for the data. And like I said, you can also see the activity on a feature group, like how many rows have been written in the past to this feature group, and so on. When have the statistics been updated the last time, and so on. So that gives you, as a data scientist, the possibility to discover new features and also decide which features might be useful for the model you want to train, right? So, and then, as I said, you want to create a feature view, selecting your features from the feature groups to train a model, right? Or to query data from the feature store. And for that, I'm going to jump into a notebook right away. If you are familiar with weights and biases, you'll probably also be familiar with this. It's as simple as importing the Hopsworks Python library, calling a login method that will basically print a link to get you to Hopsworks and create and copy an API key, and then you enter the API key in a box here, and then that's all you need to do to connect to the feature store. As I said, then you can query the feature groups, or basically get a reference to the metadata of a feature group. And in this case, I get both my feature groups. I can decide which version of the feature group I want. I select the features and join them together, right? In this case, CC_num is my primary key. I'm dropping it from the second feature group because I don't need it twice. Then I'm attaching additional transformation functions. As I said, it's very important to do that when reading the data from the feature group, because otherwise the features in the feature group are model specific. So that's why in our solution, you need to attach the transformation functions when reading the data from a feature view. And then finally, you create a feature view. You can give it a description. You can say which columns or which features are the actual labels, and you pass it the mapping for the transformation functions and the query that you defined above that defines the schema of the feature view, basically. Until that point, no data has been handled, so this is all very fast when you run it. Then once you want to actually create training data from that feature view or read training data from the feature view, you can do that with a bunch of different calls. There's methods to create train, validation, test splits. In this case, I'm writing the data as CSVs. You can also, instead of create, So not to write it as files, you could call get train validation test split, and you would get back 3 pandas data frames directly. In this case, I create them as CSVs, and then I get back the same version of training data into pandas data frames again. You could also read that from external environments, or if in fact that's what I'm doing here. This is a Jupyter notebook running on my local laptop, whereas yeah, the serverless Hopsworks instance is running online. So once we have created a feature view, we can go back to the UI, take a look at the feature view. You'll see the transformation functions which have been attached, which feature groups the feature came from, and you can also see the training data set that I have created. And you can actually, when querying training data, you can also specify time intervals in event time, basically to limit the data that you're using for training. For example, you want to use only the data from the last year or something like that. And again, you could also look at statistics as well of the training data itself. And now comes actually the part where we integrate all this with weights and biases. So where we start training a model. Again, we log into the Hopsworks, we get a reference to our feature view, and we get the training data, right? And in weights and biases, this looks very much the same. We import weights and biases, and we log into our account. In order to be able to get a nice lineage graph in weights and biases, I'm creating a bunch of artifacts, so-called artifacts in weights and biases, containing the metadata of the feature view and the training data splits that I'm going to use. So I'm collecting a bit of metadata here, write it into an artifact on weights and biases. And I'm doing the same for the train test splits as well. I'll jump into weights and biases in a second. And then the main functionality we want to use here is the experiment capabilities and hyperparameter optimization capabilities. So what I'm doing is I wrote this training function which takes our train and test data. It initializes a weights and biases run. It trains a random forest classifier. It scores on the test set, and then logs back the F1 score to weights and biases. And also it creates an artifact on weights and biases for the model. So I'm pickling the scikit-learn model and write it into weights and biases for the registry to pick it up. And then I'm executing a grid search method. So I define a bunch of parameters that I want to search over. And finally, I started this, what it's called a sweep in weights and biases, which will run my training function for each combination of those parameters. And if I go into weights and biases now, you'll see that, so here's the feature view that I created as a metadata object, linking back to Hopsworks. And at the same time, I can see the models that were created in my hyperparameter optimization experiment. I can also look at the sweep in detail to compare metrics, but also to look at log files of the single trial runs of the sweep, and so on. And then if I go back, for example, since everything is linked by the artifacts I've been using, so if I look at the transactions or at the feature view artifact and look at the complete lineage, you can see that basically I created the train test split here. Oops, sorry. The train split, the test split, and the validation split. Then I'm using the train and test split to train 6 models. And then I'm doing one more step, and I'm taking the best model to validate it on a holdout training set. And then I registered the final model or the best model as version 7 in the registry as the latest model, basically. All of this is also here in code. So finding the best model among the runs, reading up that model from that run, scoring on the validation set or holdout set. And then comes the important part. So now comes the part where we want to use the model to score, for example, new data that has been written to the feature store. So you would take this model or this code to read up a model from weights and biases and turn it into a job. And you can either run the job on your own infrastructure as a Python job somewhere. But if you use the managed version of Hopsworks, you also have the possibility to run compute on the platform. On the serverless version, you don't have the possibility to run the compute, so you would have to bring your own compute, essentially. So what you would do in production is you would query the data that has newly arrived in a certain time interval, get the batch of data. The feature view will make sure the same transformation functions, the same join logic is applied again, gives you back a data frame, and you can pass the data frame to the model to make the predictions and then write back the predictions into either the feature store or to some operational system like a CRM system to use them. In this case, because I want to make Hopsworks aware of which model was finally the model that corresponds to this feature view, I'm adding a tag which contains all the information I need to link it back to the model in weights and biases. And I add that tag to the feature view. You can also look at the tag. You'll see the tag here so that you can basically jump back and forth between Hopsworks and weights and biases. So now we have seen basically how to retrieve data from the feature store if you want to deploy a batch model. Now I want to show you how you can really quickly with Hopsworks also deploy this as a online model or operational model. And for that, I've created an pretty empty GitHub repo, which essentially contains a predictor template. The template, all it does is it connects to the feature store, gets a feature view, loads a model, and then it has this predicts method, which basically will be exposed through the REST API. So you send a primary key value, which will get passed ultimately to this predict method, and then returning back the prediction of the model. And then at the same time, I wrote a script which watches a directory in this repo called models to check for config files, right? So every time I push a model config to this repo, it will go through the list of models, load the model from weights and biases, template the predictor, and create a deployment for it on Hopsworks, and also start the deployment. So I'm quickly gonna start this now. I just need to push one commit. So this is done, which should start the action. Yes, it did start the action. The action basically installed some dependencies, Hopsworks and weights and biases, and then execute the script that I've shown before. Since this takes about 2 minutes, mostly installing pip Python dependencies, I've already created a deployment here, which is already running. Once this deployment is running, you have your Rest endpoint that you can send primary key values to, basically passing the primary key value to the predict method, which then will call the feature view to read up and reproduce a feature vector from the feature store, and then pass back the prediction. This is configured to scale to 0. So what that means is that it shuts down the serving container if there are no requests coming for a while. So that's why this first request took a few seconds now, but now it should go much faster. Yes, so it gives me back prediction 0. So in that case, this transaction would be non-fraudulent. Okay, so this pretty much concludes the demo. If I go back, I think we have a few minutes for questions, not too much. I hope you can stay a few more seconds. Let me pull up the questions on Zoom. Okay, so Adam is asking, in your demo, you assume the data arrives in batches. Would this work also with a stream of transactions? Yeah, so in this example, all the data came from Pandas data frames, but if you have access to Spark and you can ensure connectivity between Spark and Hopsworks in the managed version, or you can also run compute on the managed version in Hopsworks, you can run Spark streaming jobs, which would allow you to also cover streaming sources of data. Then another interesting question. So weights and biases offers also dataset versioning. Why wouldn't you use this? So the main reason, yes, you're right, Lynn, weights and biases offers dataset versioning, but I think it's mostly useful for training models and yeah, if you're experimenting a lot, that's very useful, even though we do it on Hopsworks as well. But then once you want to take a model and put it into production, you need to know which time intervals it has been trained on. And you also need a way to version in terms of event time. So to get newly arrived data for scoring, right? And that's where the feature store can help you, and where the feature store is different from the dataset versioning of weights and biases. And then maybe one more. What's the benefit of using multiple frameworks together instead of using one like SageMaker? Yeah, you can take a solution like SageMaker that has everything built in. However, by using Hopsworks and weights and biases together, two tools, basically what you get is what we call best of breed. So you get the serving capabilities from Hopsworks and the great model development capabilities of weights and biases, and also you in a way you prevent some kind of vendor lock-in, I would say. I think we're tight on time, so I'm going to stop here. If you have any more questions, we'll try to answer them via email. Otherwise, thank you very much for listening. Sign up on hopsworks.ai or join our communities on Slack. Thank you very much.